Type of word problem I have here is a standard form type word problem. I'm going to show you how to solve this type of word problem, and the scenario in this case is that the length of a rectangle is 5 centimeters greater than its width. The area is 104 centimeters squared. Find the dimensions of the rectangle to the nearest hundredth of a meter. So solving this is actually very easy because all we have to do is set variables and use the area and quadratic formula. So basically what we do is I'm going to start off by writing two let statements to define my variables. So I'm going to say let x represent the width of the rectangle in centimeters, and let x plus 5 represent the length of the rectangle. In centimeters. Okay, so I'm going to start off by first drawing a diagram. That was a pretty bad diagram. So okay, I can't draw, but I'm gonna try to do my best. Alright, so it's pretty good. So the area is 104 centimeters squared. The width is x and length is x plus 5. So that is my labeled diagram. So what I'm going to do now is write the area formula on one side. So length times width. And now I'm going to substitute whatever information we have. So we know the area is 104. The length is x plus 5. The width is just x. So now I'm going to try solving. So x multiplied by x is x squared, and x multiplied by 5 is 5x. Now I'm going to try putting this equation into standard form by putting one side equal to 0. So that is my standard form equation. What I'm going to do now is find my value of x, and I'm going to do that by using the quadratic formula. So the quadratic formula is x equals to b, just messed up, negative b plus or minus square root and b squared minus 4ac divided by 2a. That is the quadratic formula. Now, from this equation, I can see that my a value is 1, my b value is 5, and my c value is negative 104. So what I'm going to do now is substitute it inside my equation. And I'm going to do that like this. So b is 5, so I'll put negative 5 plus or minus. So, and then I'm going to do 5 squared, subtract 4, a is 1, and c is negative 104. And then I'm gonna Okay, now that I have this, I'm going to use bed mass and solve. So I'm going to write bed mass on one side. Bed mass. You can see that? Yeah. So I'm going to be using bed mass, which means I'm going to be solving brackets first. 5 squared. Okay, alright, so 1 multiplied by negative 104 is negative 104. And then this will be 2. Now I'm going to do the other bracket left, which is 4 times negative 104 is 416. So that is my answer right now at the moment. I'm going to keep solving till I get a single constant underneath my square root sign, and the rest of my equation looks single out. So 5 to the power of 2 is 25, and plus 416. And then we're going to divide this by 2, and x equals negative 5 plus or minus 416 plus 25 is 441. And now I'm going to divide that by 2. Alright, so that is the farthest point I can do. That is my exact root. But if I were to write an exact root, I would do 1 would be with just positive and 1 would be with just negative. So that is just like the second last step towards my exact root. But we're going to find it in a decimal format. So I'm going to do x equals to negative 5 plus 441 divided by 2 on this side, and x equals negative 5 minus 441 divided by 2 on this side. So I'm going to have 2 x values, and from those 2 x values I will choose which one is most accurate. So I'm going to continue on solving this. So the first one I will be doing is the positive one. So if you can see on my calculator, negative 5 plus the square root of 441 is equal to 16. Now that is just the top part of my answer, so I will do 16. Now I still have to divide by 2. So if I divide 16 by 2, I get 8, like that. So this is one possibility for the length, which is 8 centimeters. And the other possibility is using the negative way. So negative 5 minus 441, which gives me negative 26. Negative 26. But I'm still not done because I have to divide by 2, and when I divide by 2, I get negative 13. So by looking at my answers for the x values, I can see that negative 13 is not a reasonable length, which is why x equals 8 is my final answer. So that only tells me the length. And the question is asking about the dimensions. Find both dimensions. So I'm going to actually write width. Width equals x equals 8. So my width is represented by x, and x is equal to 8. My length is equal to x plus 5 equal to 8 plus 5, which equals to 13. So therefore, the width actually of the rectangle is 8 centimeters and the length is 13 centimeters. So that's my final answer for dimension word problems in standard form.